Hi, everybody, and welcome to our webinar today entitled Safe as Clouds, the Journey from Legacy to Cloud Native Security Principles. So this is our VMware story of how we moved from our sort of legacy security principles into more of a cloud native, hybrid cloud, if you will, security stance. My name is Craig Savage. Hopefully you guessed that from the fact I'm talking. And let's talk a little bit. Who am I? Why am I entitled to talk to you guys about this stuff? My most recent certification that I added was the Information Security System Management Professional, the ISSMP add-on to my CISP. I've worked in security for a very long time, as you've probably guessed by my magnificent beard with highlights in white. I've worked around the globe, really. As you've probably guessed from the accent, I'm not a US native. I did a lot of work in Europe and Africa. I've been in the US now for a couple of years, working out here as well with VMware. My focus really is on security outreach for VMware. How do we help our customers learn from some of the stuff that we've done? Because we deliberately try and push the envelope, if you like. And this is really a practitioner to practitioner session where I'll be sharing with you some of the stuff we've learned in the hopes that you guys can leverage that information to accelerate your security journey as well. You may have gathered from that, as that last point says, I'm pretty passionate about security and making it simple. So let's step into what we're talking about today. So already done the introduction. I'm Craig. Talk a little bit about VMware InfoSec, who we are, what we look after, what our mission and vision is, if you like. Give you some insight into VMware as a company and why our experience is actually quite relevant to most corporates around the world. Talk through some example security principles. It's not an exhaustive list. You'll be glad to know we're going to go through every single one. We'll talk about the key ones, why they matter, and how they've transformed. A little bit of a wrap up, obviously, at the end. Lots of time for questions. If you've got any, as Sakura said, please type them in the question box. We will get to them at the end. There's other ways to reach us as well, if you think of questions later, and we'll cover that towards the end, and then obviously close out. So, who's VMware? Who's VMware InfoSec, more importantly? We call ourselves security and resiliency. We look after pretty much every aspect from physical security, personnel security, to cybersecurity at VMware. A lot of people interact with VMware via our sales functions. You're familiar with your account manager. If you're lucky, you've got a technical account manager, a TAM. They're a superb ambassador for helping you move your technology estate forward. Sometimes you've had the benefit of our PSO, our professional services organization, doing some work for you, but not a lot of people understand, because VMware still acts very much like a startup, just how big we are as a global company. So I thought I'd give you a bit of an insight into that. Don't worry, I'm not going to read this whole slide at you. There's a lot of information on here, and we pick out different bits depending on the audience and the topic that we're talking on. Main ones I want to pick out for us today that are relevant to what we're talking about, security principles, be there on the left. 7,500, give or take, ESXi hosts, so that's kind of production virtualized environments. No surprises, all of our estate is virtualized. Hello, we're VMware. Running about 24 data centers around the world. That number changes slightly, obviously, with mergers and acquisitions. We generally try and manage towards around about 24, give or take. Rate of change. So this is something that I think we're kind of unique in. There's not many companies that have this kind of rate of change. We have some in the region of, I know the slide says 2.2 million, probably trending closer to 2.5 million by now. Containers created and destroyed every week, 1.6 million. Again, that number will also be growing. Virtual machines created and destroyed every week. So those, if you like, are the more fully fledged workloads. Now you can imagine as a security function, if we were still trying to deploy a security stack, do compliance, make sure it's embedded in the CMDB. With that rate of change, well, we'd either have a team of thousands who were all suffering burnout, or we'd have completely overloaded whatever technology stack. So we've had to think of some clever ways of keeping that kind of rate of change secure, without applying the old legacy mindset. And that's kind of what we're going to talk about today. 91,000 persistent VMs. Again, that's kind of our production state, if you like. We've got a lot more VMs, not just the ones that are created and destroyed every week, but a lot of others in non-production environments. And that's probably about it for this one. We're always happy to talk about some of the other stuff that's on here. If you want to talk about how we use some of the products you see on here, reach out to us. Like I said, the contact details will be at the end. So what are we as security architects at VMware? So we function as one team, as architecture and engineering. We work really closely together. We also have a product engineering team, kind of a DevSecOps, if you'd like. And we all work really closely together to make sure we're doing the right thing in the right way for our company. But fundamentally, this is what we're trying to achieve. VMware is all about innovative disruption, so we try and be as well. That might sound like a bit of a bad thing for a security function to be disrupting, but what we're looking at is, let's disrupt those old mindsets. Let's disrupt those old ways of doing security and try and find smarter, better, faster ways of delivering a secure environment and an easy user experience. Functioning like a service provider. I know this is a bit of a cliche in our market at the moment. Everyone's kind of really interested in this. Oh yeah, we act like a service provider. We've taken that to heart. We really look at, how do we deliver this as a service? How do we provide metrics that we're being effective? How do we, that's the key thing for us, is how do we accelerate new service implementation? So our business is all about doing stuff fast. And the traditional security function is all about slowing everything down. So we've kind of gone, right, actually, how do we make sure we can make our business move even faster? How do we delight them with the security experience is kind of where we're at. And as I've said a couple of times already, it's all about keeping security simple. How do we keep it simple, non-complex? It's just really easy to comply. There's no funny hurdles to jump through. There's no, miles and miles of red tape, documents to fill in, procedures to follow, because all that stuff just results in your users going around your security. And we really want them to have security as the simplest option, the easiest path to success, if you know. And this sounds like a big thing to do, but actually security is already in our DNA as humans, as professionals in the workplace. And all we need to do, and this is what we've been focusing on, is tap into that innate security mindset that most humans have. We know when an environment feels unsafe. We know when something feels risky. So how do we bring that into that experience in the workplace and go, hey, we'll use phishing as an example, right? That email looks too good to be true. Don't rely on the security technical controls. We've engineered a thing with our email clients where we've just got a little button that says, hey, I think this is phishing, and it sends it to our security operations center, and they can analyze that email and figure out whether it was a phishing email or not. And you get like almost real-time response back saying, no, the email looks okay, or yep, this looks dodgy, so don't do anything with it. And that's all we're asking our users to do is like, hey, this looks like that dark alley with no lights and a couple of shadows lurking. Maybe you don't want to go that way. Apply that same logic in your day-to-day life as a professional in the workplace. You don't need to be a security person to engage that inherent risk awareness that most humans have. So that's kind of what we're trying to bring out in our people. As you see there, take risks. Business is about taking risk. As a security professional, we really have to understand that. Our business is designed to take risks. That's how they make profit. They keep talking about risk versus reward. And so our job is not to, stop them from doing stuff because the risks, right? We need to be able to help them quantify risk and be able to understand from our perspective. And then we need to understand from their perspective, is this a risk they're likely to tolerate? If so, what compensating controls can we put around it to minimize the impact? Right, that's the reality of a modern security professional. So let's talk about what we call our foundation, the 5 pillars of cyber hygiene. This is still so relevant. Most of you will look at these and go, yeah, we've been talking about this stuff for years. Yeah, we have, because we still need to get better at it as a profession, as an industry, as a mesh of people joined together. Patching, for example. How many times have we seen exploits, and hacks over the last 6 months, frankly, that are a result of people not having patched effectively? A known vulnerability with an available patch being exploited by an attacker because that company hasn't had their patching regime up to scratch. Basic stuff. We've been talking about this for over 20 years. I know, because that was one of my first things when I got into InfoSec, was sorting out a patching schedule. Culture is super important. We think that underpins everything. Like I said, you kind of got to have that open and communicative culture. If someone makes a mistake, the most important thing they can do is put their hand up and say, hey, I've just realized I did a really dumb thing. And then the team works together to fix that thing. And that doesn't need to be like a big fanfare and, they have to stand up in front of a cast of thousands and declare their error. But what we don't want is people hiding their mistakes. They've mispatched something. They've, in error in a data center, patched a DMZ connection into the production network, which has just created a complete, bypass of the firewall. It happens. People make mistakes. What we want is someone to go, hey guys, whoops, I did this. I realized I corrected it, but it was probably there for about 4 hours. Now we've got an opportunity to go, hey, did anything happen in that 4 hours? Let's do a quick scan of that environment, with more scrutiny to go, did anything get in? Whereas if we didn't know, if it just gets covered up, you've potentially let an intruder onto your network unsupervised, and nobody knows until they actually start doing something. That's what we mean by the open and communicative. Next-gen authentication. Again, this is not new, but it's gaining ground now, which is really good to see. Starting to see a lot of companies, pardon me, starting to really take this to heart. This multi-factor authentication. It's got so much easier now that we've got more sort of push authentication, rather than you have to get a hard token out your laptop bag and push a button and type in a code. And that was hassle for a user. It wasn't an easy user experience. Whereas now you go to a website, or you go to a service, in our case, internally on our network, it needs to do step-up authentication. So it's confirmed you are who you say you are, it's confirmed your device, but it's a sensitive service, like our security tool set or finance tools or whatever. And it'll send a push authentication method to your phone. And you just say, hey, yep, it is me doing this, and you're in. Easy user experience, users use it, users love it. Keeps us much more secure. Managing identity, again, this is something we should be doing. What I think, certainly what we found was when we talk about managing identity, everyone would go, yeah, we've got everything in a directory service, Active Directory, LDAP, whatever your choice is. But what often gets forgotten is all the systems that aren't integrated to that. Your network devices, your old Unix servers, that kind of stuff. How do you manage those? How do you keep that central identity? We talk about least privilege. How do you manage least privilege if you don't know where that identity exists across your entire estate? So that's the scope to think about now. Microsegmentation, this has been a thing for security for ages. There's an increasing number of tool sets. No surprises, VMware's got what I consider the market leader, NSX. It's getting simpler to do, it's getting easier, it's getting faster. If you're not actively considering microsegmentation, you're in trouble, quite frankly. That's the only way to stop some sort of lateral movement on your network, convincingly. Everything else is about detecting it. The only things that really stop it is effective microsegmentation. And then encryption. Again, old school. We've been talking about this for ages. Making sure stuff's encrypted at the right place in the right way. So again, we keep getting this question at VMware, is your network traffic encrypted? Well, our network traffic is encrypted where it needs to be encrypted, And it's not encrypted where it isn't, because we need to be able to do our network analytics. We need to do our security checking on the traffic, right? If you encrypt your entire network, you've suddenly made all of your security tools blind, right? So that's where you need to apply that principle of, is it effective to encrypt where we are? But certainly endpoints and any data to and from an endpoint should be encrypted. In this day and age, there's really no excuse not to have full encryption on every device. So let's talk about our 3 key activities. Scanning. So in our instance, where we talk about scanning, we're talking about ways to make stuff better. So this is a human activity where we are actively looking at the systems and processes and going, can we make this better? Can we make it faster? Can we make it more intuitive? Hygiene. So as we just covered, there's the 5 pillars. Living them and being meticulously secure. This is important. You can't sort of half-heartedly do that kind of stuff. You have to be robust in your approach to implementing those hygiene things. It's not like we have a shower every other week, right? Most of us have a shower every day because hygiene is important. We know this, it has health benefits, etc., etc. It's the same with corporate systems. Monitoring. So now this is the technology level. As compared to scanning, this is making sure the systems are doing what they should be doing and looking for those anomalies. So this is more than just pulling in all the logs, right, and having one giant data lake that you run analytics across. This is about establishing that baseline, understanding what good looks like, understanding what normal traffic patterns look like, so that you can detect when something's different. Again, that's kind of easier said than done in this current day and age. A lot of the tools are moving into that space. We've got some of the stuff that's coming out in our network detection and response line is directly targeting that kind of stuff. So we can talk about that if anyone's interested. So let's talk about these principles. Right? Like I said, these are just a few, just to give you a flavor. I like this dictionary of definition of cloud as to obscure. How many times have security controls relied on obscurity? Yeah, it's like, oh, it's obfuscated, it's fine. No, not really. Let's be real. We can't rely on secrecy or obscurity for effectiveness. Okay, we still get customers to this day saying, oh, we won't allow our IP addresses to be in the log files when we send them to you for diagnostics. Why not? You're telling me a competent attacker can't figure out or hasn't already figured out your IP addressing scheme before they even get on your network. And it's not through diagnostic logs going to a supplier for checking. You can't rely on secrecy. Secrecy is not a good security control, right? And let's be blunt, almost every big corporate uses a 10. IP address range. Smaller corporates use the 172.16, right? Really small uses the 192. We know that. What's important is what's living on those IP addresses. Yeah, what protecting your DHCP database or your IPAM or that kind of thing. That's important. Letting people know what the IP addresses are hardly relevant in this day and age, right? We've covered that to death. Important thing to note here is security control should be open to evaluation, right? As soon as you say, well, we can't tell people about that security control, refer to the principle, which says you can't rely on secrecy, right? It must be open to scrutiny. People must be able to look at your security controls and go, that doesn't seem very robust. Have you thought about it? Because in that way you get better. Otherwise, when you just keep locking people out of your security controls, you're in a very locked-in environment where innovation is not going to happen, and you will get exploited. So a question I get asked quite a lot is, are the fundamental principles of information security still valid in a cloud environment? Yeah, confidentiality, integrity, availability. Absolutely. They've changed slightly, but they still fundamentally hold true, right? So we're still about ensuring the protection of sensitive systems and data, confidentiality, right? Still about that. Now, like I said, what's changed is in the old days, on-premise days, we owned the whole stack. right? So we own the network, we own the firewalls, we own the server hardware, we own the operating systems and virtualization nodes that lay on top, etc., etc. Yeah? So we own the, if you take the old OSI 7 layer model, we owned all 7 layers effectively. Maybe not the 7th, but generally we owned enough to be able to conclusively go, yeah, we can do this. Now in a cloud environment, we probably only own the sort of application, maybe, but the data level up, if that makes sense. So you don't necessarily own the underlying infrastructure. So there's an implied trust there that you need to understand and be able to understand whether that trust is sufficient or you need to apply the zero trust principles, because actually we don't trust that at all. So how do we design confidentiality into the bit that we own? Because we can't trust the underlying infrastructure. That would be my recommendation, certainly. Availability, exactly the same thing, right? Ensure services function as purpose and function, right? Dictionary definition, if you like. How do you do that in the cloud? Exactly the same thing. The common mistake that we see happening is people go, hey, it's on a cloud platform. It's 100% available, 99.999, whatever percent available. Cloud platforms do go down. We've seen this, right? It's, every couple of months there's some sort of outage on one or other of the cloud providers because it's still based on hardware. Now, if you've got a single instance running in a single zone on a cloud provider, and that zone happens to go down, well, you've got an outage. You've just failed the availability clause, right? So it's same rules apply in a cloud. You don't have, again, control of the underlying infrastructure. So what you need to do is think about, how do I make my data an application? Because that's really where zero trust focuses, applications and data. How do I make sure that's available with integrity? The last one of this, right? Exactly the same thing. If I assume zero trust in the underlying infrastructure that's provisioning this, how do I ensure that what goes in and out of the environment, what I'm trusting, if you like, the data and apps, how do I make sure that it has integrity? Interesting case in point that we had the other day, there was a discussion in our architect forum. If you are recovering from ransomware, for example, and you've got the decrypting tool, how do you know that the data it's recovering is accurate data? Because have you kept some sort of integrity checksum somewhere? Have you kept some form of, so there's an interesting thought experiment for you to do in your own time. How do you know if something that you've had to recover, now from backup, you've got a reasonable expectation that there's integrity because you've probably done a verification on your backup and you know it was good. How do you know if you're decrypting stuff that what you're actually decrypting is your data? Interesting thought. So let's talk about some pairs of principles. Now, this is one of the things that I think changed when we started looking at our sort of hybrid cloud or cloud native type security principles, is our old, let's call them old principles, the stuff that applied to on-prem. We tended to have a single standalone principles. And one of the things we've noticed with the cloud principles is they kind of come in pairs. There's always a link. One principle depends on the other, or there's some sort of independence. And those are the ones I want to talk about today. So there's only going to be 3 pairs that we're going to talk through because that'll probably take up most of our time. So this one, the value-based security control, right? You have to understand the risk in order to be able to design a secure solution. You have to be, as part of designing a secure solution, understand the risk that that system's going to be exposed to, okay? So it's linked. Because you could design a super secure system, but the system holds, no data of any kind of value. It's not of any kind of importance. It's just like, I don't know, some sort of thing that churns air quality metrics for your office or something. Certainly important, but not business critical. And now you've made this like Fort Knox security. So you've wasted money. You've cost your company money by putting inappropriate levels of security around something because you didn't understand the risk. Likewise, and we still see this even today in 2021. We still see people building systems, building, especially websites, web platforms, without sufficient security built in because they didn't understand the risk. Right? It's like, oh, it's just a little website. It's just an information thing. It's like, oh yeah, but you've got people logging in. Oh yeah, because we want to track, who comes to our website. That's why we've got that kind of, but now as soon as you put authentication on your website, you've got a database of usernames and passwords and email addresses. So that's kind of valuable to hackers at that point. Oh yeah, I didn't think about that. Right? So same thing, you have to do this, the risk piece to be able to do the design piece, and you have to be able to do the design piece to properly understand the risk that's going on. So that's why we've linked these two principles. And we've built this into our process as we build stuff nowadays. We work with the build team, we ask them to engage early. We explain to them that this is the reason why we need to be engaged early, and much better stuff comes out as a result. It's an iterative thing. We get better every time we do it. But bear in mind, that's probably the most valuable pair. Installation. So again, this is another coupling of two principles. We've given it the name installation. Because what we're joining here is this concept of whether you call it defense in depth or microsegmentation, or we'll talk about that in a sec, and least privilege. Okay, so here we've got this concept, defense in depth. A lot of security professionals are kind of moving away from defense in depth as a term because it kind of applies to that legacy security mindset where you've got multiple layers of security controls. I still quite like it as a concept. I think it still applies because when you think of defense in depth, to me, what you're thinking about is how do I make sure I'm not relying on one control point, one security control, or just like a really small number to ensure that this service is effectively secure. That to me is what defense in depth means. So that for me is looking at how do we compartmentalize the service, how do we microsegment it, in other words, and that concept of establishing what good looks like, right? Because that to me is a key fundamental of zero trust. You have to understand what the system looks like when it's operating normally to be able to effectively understand the controls you should be putting in to effectively have that alignment to the zero trust architecture. Because that gives you clues to what you should be trusting, in other words, more simply. And we link that with the least privilege, because again, this is, least privilege, access to resources denied by default. It's been the holy grail of InfoSec for ages. Provision based on the concept of least privilege. Yes, everyone's nodding. And dictated by business requirements. Most people don't nod at this point. They're like, no, it's dictated by security. Right? So again, now we're starting to design with this join principle in our cloud native world of, okay, so now I'm designing this cloud native service. It's sitting on one of the major cloud providers, VMC on AWS, Glue Cloud, Azure, whatever. How am I ensuring that not only have I got sufficient controls around that, without being onerous, so it's effective defense in depth, but as part of that defense in depth, I need to consider least privilege. So how do I ensure that only the people that should have access have got access, and only access to the things they should have access to? And that's kind of the key interplay between these two, because how do I set that zone of defense that says this is what users should get to, and this is how I detect if the users burst out of that bubble. That's what we're looking for in defense in depth these days. And then something else that's super important is containing privileged credentials. Right? We see so often in hacks these days, the first thing they do, if you look at the the trace of what the aggressor did, first thing they do when they compromise the device is do a credential dump. Right? They dump credentials. They do what they can to try and decode the passwords that came as part of that, and then they use that to move laterally. And the holy grail for them is admin level privileges, right? That's what they want to get to. So when we talk about least privilege, we're super concentrated on how do we make sure that admin credentials aren't present on anything that's, let's say, easily exploitable, right? So we try to make sure that our administrators don't log in with their admin accounts on endpoints, for example. Sounds pretty simple. something we've been trying to do for years, most companies. It's become really relevant now because if a Windows administrator, for example, has logged in with their privileged account, those credentials are now available if someone compromises that endpoint. Endpoints are a significant vector for the hacking groups, right? That's what they go after. That's why most of the hacks come in via phishing emails. They very, very rarely manage to penetrate the data center without having first come in via end user compute device, right? So, yep, we put all the controls, we put our defense in depth on the end user device, right? So we've kind of got that part of the puzzle. And then what we look at is the least privileged side and go, hey, how do we make sure we don't give them anything useful on that endpoint? That's the least privileged. So, for example, we don't join any of our endpoints to our domain. So there are no domain credentials. That's by design. We haven't seen any productivity impact from that decision, but we do see a security advantage from that decision. So it's that kind of thing that I would encourage you to think about when you think about these principles, is how do we start to link least privilege and defense in depth? And then the last pair I wanted to talk about, we kind of call the plan, do, check, act. Those of you that come from the various project management disciplines or ITIL, something of this form exists in every single one of those. What are we saying is, plan for what you're going to do it, check that it's doing what it's supposed to be doing, and then act on that result, right? A lot of people forget that last bit. They plan a system or a product, they run it, they check, they go, yeah, it's not quite doing what we want. Oh, well, next, right? You have to go back and figure out. And that's where we've linked these two principles together. So it's plan for failure, right? Especially if there's human interaction on that system. Humans make mistakes. Let's stop pretending they don't. Let's, as professionals, admit that this happens. Even we make mistakes. Let's plan for them here. And again, not to like minute detail, because it's defense in depth again. How do we plan for reasonable failure scenarios so that we can make sure that we can detect them, right? Because that's the important thing. It's not preventing them, it's being able to detect that something's gone wrong so we can do something about it. That's the do, check, act bit of this. And then standardizing and automating. So again, this is linked because one is plan for failures. What's our biggest failure criteria? Humans. So what do? We automate to take the human out of the failure path, right? Pretty simple. The other thing to bear in mind, especially when it comes to, so standardization is super useful because it means you're doing the same stuff in the same kind of ways, which means it's easy to detect anomalies, right? If it's just hey, we just get stuff done, it's a bit of a mess. How do you know when something's not working properly, right? So that's the important thing of standardizing processes, make sure people are doing stuff in the same way. Also limits human failure at that point, right? This is why things like production lines in factories are so effective, because if that one person's station is they put the engine on the lawnmower and put the 4 bolts in, they're very unlikely to get that wrong because every time put engine, put 4 bolts. That's the standardization aspect, and I'm not saying we want that kind of behavior from our people, which is where automation comes in, right? Once you've managed to standardize a process, once you've managed to get it to that level of simplicity and ease, now we can automate it. Because as I like to say, the only thing you get from automating a bad process is bad stuff faster, right? It's all automation really delivers is speed. Right? It doesn't deliver quality. Quality is the human aspect, right? So you have to make sure the quality is there, then you accelerate it using automation. Now that's where we get away from the human having to put the engine on the lawnmower and put the 4 bolts. Now we've got a robot doing it. And now what we've got is we've got the human checking that it's doing it correctly, right? Or if there's a failure condition, the human takes action to correct the failure condition, which is that last point there about human validation, right? You do not want your people in your security operations center actively monitoring log files, watching all the errors scrolling up their screen and trying to pick that needle out of the haystack of what's actually anomalous behavior. That's an incredible waste of time. It's an incredible waste of human energy, and you will burn people out because it gets very boring and very monotonous really fast. And people's attention spans just don't last for that kind of thing. right? So what you want to get to is where on a security operations center, a SOC, now you're getting an alert coming in that says, hey, we've detected this anomalous behavior on this workstation being used by this user in this geography, that normally does this. Now the human's got sufficient information to make a human level decision to go, yeah, no, that is unusual. Or, oh, I need to investigate further. I'll give the guy a phone call or send him an email or whatever. All right, so that's why these two link up. Plan for failure, mostly the human one, although, like I said earlier, the assumption tends to get made that cloud platforms are permanently available. No, they're not. So that's another plan for failure criteria. What do you do if it goes down? What do you do if your internet infrastructure goes down and you cannot connect to your cloud infrastructure anymore? Another important thing to consider. And then standardize and automate. Yeah, make the human job an interesting job, and you'll land up with better people that they're prepared to stay for longer. How have we done this? So we started with our security community. No surprises. Not just InfoSec in that traditional sense. We have security relevant people, for want of a better word, out in our various business units as well that look after product security, look after their development environment security. Worked with all of them to try and embed these new principles. Then we worked with the DevOps communities. So again, once you start building these principles, remember the one about the risk and least privilege, the security built in and the risk, right? That's where we start to have the conversation with the DevOps teams around, hey, you're building this new product. Can we understand what it's going to do so we can assess the risk? Can we feedback the risk that we've things so you can make sure you've built in the correct level of security into your product without wasting time or energy and without under-speccing it as well, equally important. And we're now in that phase where we're moving it out to our entire user base. Again, this is something that tends to get overlooked, right? Human error still exists in finance and HR. They're not immune, right? They just have different impacts from some of the mistakes that they can make. So same thing, building management, for example. This is the thing at the moment. A lot of building management systems are now suddenly connecting to cloud services so that they can do, we've got running in our California office that connects to the electricity grid to check the current electricity price, and turns things off and turns things on depending on where the price is to try and, optimize our electricity spend. Great in concept, but when you think about that and you kind of go, hey, hang on, you've just connected the power systems in our offices to the internet. Again, have we understood the risk? Have we built the correct security controls in place? That's why you need to start reaching out to more and more of your business, because more and more of your business is connecting out to the internet. It's becoming more and more attractive for various reasons to other functions that maybe traditionally didn't have an internet connection or need for an internet connectivity to connect their systems out to the internet. And getting ahead of that curve and getting in front of those people to go, hey, how can we help? Super important. So while you guys are thinking of any questions, please do type them in the Q&A thing. I don't think we're going to have the ability to do open mic. Pop your questions in. We'll get to answering them in a second. Hopefully you've seen how important it is as we've run through this to kind of still keep on the basic hygiene things, the 5 pillars that we talked about, keep them front and center, patching, microsegmentation, multi-factor authentication are super, super important. Think about how you link principles together, how you create those interdependencies that helps your business understand better why these things matter as well. When you've got the linked pairs, because they can understand that seesaw effect that comes from having the linkage. And I really hope you got something from today on how we have implemented this and taken this forward within VMware, and hopefully that's given you something to think about. If you want to talk about this more, there's many ways to reach us. These are probably the easiest ways to keep up to date with some of the, like I said, the more practitioner to practitioner conversations that happen with VMware. There's our email address. It's the VMWonVMWare program. We've shortened it because it was a really long email address. There's VMWonVMW vmware.com. Reach out to us. We'll happily have a more in-depth conversation if you wish. This is our blog site. We write about this stuff quite regularly. Our company site, if you want to go and have a look at our landing page on the main vmware.com website. And obviously we're on Twitter as well. Feel free to tweet us. I'm on Twitter too, so give us a shout. And I hope you had a great session. I hope you enjoyed what I had to tell you, and I'll look forward to taking questions in just a second.